In the area of scrap, we've got a customer ordering an airplane. Airplanes are expensive and must meet the specifications of the customer. Let us say, hypothetically, that the customer only wants a certain type of steel to be used. This particular type of steel does not absorb the lightning as much as some other steel would. In our Lego airplane simulation, we are counting on this steel to come from the supplier. Our engineers test the steel regularly because the supplier, once in a while, delivers a bad batch. This inspection happens at 2 p.m., which is 6 hours into the 8-hour workday. After inspection, guess what? We got a bad batch of steel, or a bad batch of Lego. All the airplanes that we've produced thus far during this shift do not meet the customer specifications. We ask ourselves the following question: how much would it cost us if we were to tear them all apart and redo them again? Because the wrong steel was used, what we have now represents little more than a scrap cost. In essence, what we are saying here is, what if the steel was bad? What is our exposure to this problem? Our exposure is the number of assemblies times the cost per assembly. It makes sense for us to say then that in order to minimize our exposure to this type of potential scrap cost, the amount of inventory in the plant should be kept as low as possible.
Now, let's take a look at what our scrap exposure is for the Skyview Airplane Company. This table shows all of the scrap cost calculations. Our first step is to count the number of assemblies between Workstation 1 and 2. We count all assemblies that are either finished in Workstation 1 or in the queue of Workstation 2. Each Lego piece in our assemblies has a cost. The 16-pin pieces are $10,000 each. The 8-pin pieces are $5,000 each. And the 4-pin pieces are $3,000 each. The number of assemblies between Workstation 1 and 2 is 22. At 2 16-pin parts per assembly, the total number of parts is equal to 44. 44 16-pin parts cost $440,000. The number of assemblies between Workstation 2 and 3 is 9. This time, there are 2 16-pin parts and 5 8-pin parts per assembly. This works out to 18 16-pin parts worth $180,000 and 45 8-pin parts worth $225,000. By following the same train of thought, we see that there are amounts of $120,000 and $240,000 for assemblies that are exposed between Workstations 3 and 4. At the 6-minute mark, there are no assemblies between Workstation 4 and 5 yet. The total cost for the 16-pin sub-assemblies is $740,000. For the 8-pin sub-assemblies, it is $465,000. And there is no total for the 4-pin sub-assemblies yet. The total scrap cost is calculated to be $1,205,000. If SVI had sent us the wrong type of steel, the manner in which we produce airplanes in day 1 would have cost our company $1,205,000. It makes sense that we should keep the number of sub-assemblies between our workstations as low as possible. If you wish, press the pause button and study the table for a moment before moving on to the next part.
Stop.